Using mean to describe a distribution, students will be able to calculate the mean and standard deviation of a distribution. Before, we previously looked at how to calculate the median and to find the IQR as well as construct box plots. But today we want to look at a different measure of center called the mean. Now, I know a lot of you guys know what the mean is, but let's just review. The mean is found by adding all observations in your sample and dividing by the number of observations. Now, this might be new for you. The mean of a sample is called X bar, drawn with a short bar over the X. You're going to have to get used to this symbol and a lot more symbols to come. But know that the mean of a sample is called X bar. The formula for finding X bar can be shown here. X bar equals X1 plus X sub 2 plus X sub 3 all the way up until X sub n divided by n. Now understand that each of these X sub 1, X sub 2 represent a number in your sample that you have recorded. Now, the mean of a population is called mu. This is different from the sample in that, let's say we have a population of 150 Bed-Stuy students that I'm interested in learning something about. If I find the mean, let's say GPA of all 150 students, I would use mu to represent this mean. However, if I only take a sample of, let's say, 10 students, and I find the mean of those 10 students, I use X bar to represent that mean. We want to be able to distinguish whether or not we're speaking about the parameter or the statistic. So let's investigate these following numbers. The following values are the number of pets of a group of elementary school students. Go ahead, take a minute, calculate the mean, and come back to me. Pause the video, come back to me, and you'll see if you got the same thing that I got. Okay, so if we add all of these together, we get 45, and we divide by the 9 observations that we have in this sample. So 45 divided by 9 equals 5. We can think of the mean as the fair share value. This means that each child would have 5 pets if the total number of pets was still to be 45 amongst these 9 students. So we want to think of the mean again as a number that would be the fair share to spread out the sum of the values amongst all the different individuals in the sample. The mean is a measure of center. However, we can also measure variance or variability with our standard deviation and variance. Now, these terms are related directly to the mean. So the standard deviation and variance tells us how far our observations are from the mean. We got to get into what this actually means. But I do want to show you a few more symbols that you will need to learn. For a sample, standard deviation is S of X. While for a population, your standard deviation is sigma. Variance is X sub X squared. So that means your standard deviation, whatever that value is, square it and you'll get your variance. And then for your population, it would be sigma squared. It's okay if these symbols are a little bit confusing at first. It's the first time you're seeing them. Give yourself some time to learn and integrate them into your new statistics speech. I wanted to go over the definition of deviation very quickly. It's a noun. Generally speaking, the word deviation means the action of departing from an established course or accepted standard. But in statistics, deviation actually means the amount by which a single measurement differs from a fixed value, such as the mean. So if I found my mean, I want to know how much does the child who has only 1 pet differ from the mean. And we're going to look at doing that in a second. So how many pets? In this exercise, we're going to go ahead. We already found the mean to be 5. We're going to find the variance and the standard deviation and take you through the process. Okay, so on the left-hand side of the table, I have listed all the pet observations, number of pets for these 9 children. Now we want to go ahead and find the deviation. To find the deviation, I simply have to take the mean and subtract it from each of my observations. 1 minus 5, 3 minus 5, 4 minus 5, and so on. Now, I could take the sum of these because essentially I want to find the average deviation. But if you notice, when I add all of these up together, I get 0. And that makes sense because I have values that are negative and values that are positive when I find my deviation. Those values are going to always cancel out and find 0. If I took the average of a 0 sum, I'm always going to get 0, so that number just wouldn't tell me anything. So statisticians had to come up with some way to find a value that would actually make sense and have meaning for our deviation. So let's go ahead and do that. So if you look at this in our squared deviations, what we're doing is we're squaring our deviations. What does squaring do? It gets rid of the negative. So negative 4 squared becomes positive 16. Negative 2 squared becomes 4. Now when I add up all my squared deviations, I get a sum of 52. This number is going to have more meaning for us than this 0 that we got previously. And let's see how. Now that we've summed all our squared deviations, we can find our variance. To find our variance, we're going to add all of these up. We got 52, and we're going to find the average by dividing by n minus 1. I know that when we find averages before, we normally divide by n, the number of observations in your sample. But this is a little bit different. We use n minus 1 when we're finding the variance of a sample. And we'll talk about this more in class, why this is the case. But 52 divided by 8, and we get 6.5. 6.5 is my variance. Awesome, we found our variance. Now the problem with using variance is that we just squared all our deviations. So before we were counting pets, and now we've squared it, so we have pets squared. Pet squared doesn't really make any sense, so we want to actually find the square root of our variance so that we can now have our units back in pets. So the square root of 6.5 is 2.55 pets, and this gives us our standard deviation. Reflection. I want you guys to pause the video for about 3 minutes and reflect on this question. Why is it necessary to square all the deviations? Take it back to the previous slide if you need to, but take 3 minutes to go ahead and answer this question and add your response to the YouTube comment section. Here are the formulas for variance and standard deviation. Now, you don't need to remember these just yet, but you will need to get comfortable with recognizing them. This weird looking E right here actually means sum. And this x sub I minus x bar is your deviations. Each x sub I refers to all of the observations in your sample. And of course, x bar is your mean. So you're finding your deviations, you're adding them all up, and then you're dividing by n minus 1 to get your variance. To get your standard deviation, you simply take your variance and find the square root. Now, we don't just want to find these values, we also want to be able to interpret them a little bit. Variance is a little bit harder because, as I said, there's no real units for variance. The variance of the total number of pets for this 9 elementary school students is 6.5. For standard deviation, we can say on average, the number of pets varies by 2.25 standard deviations from the mean of 5 pets. And that gives us a lot of information about how variable our sample was. So, overview, finding standard deviation. First, you have to calculate the mean. Then you have to find the deviation of each observation from the mean and square each of those values. So remember, when you're getting negatives and you're getting positives, you have to square all those values to ultimately get all positive numbers. Find the average of the squares. So you add all of those squares up and you divide by n minus 1. Remember, this is your variance. Last, calculate the square root of your variance, and this is your standard deviation. So this is your homework. You are going to attempt this problem. Feel free to pause the slide and copy down this table because this will help you out a lot. So it says to the right are Joey's first 14 quiz grades. Calculate the mean and the standard deviation. Interpret both in context. Remember, use this table to help you arrive at the standard deviation.